Okay, so this is section 11.1D. Couldn't finish this yesterday just because of time. Still vectors on a plane. But we wrote this out yesterday at the very end just so that you guys had the problem. And basically says two tugboats are pushing an ocean liner. Each boat is exerting a force of 400 pounds. What is the resultant force of the ocean liner? In other words, which direction is it moving? So I guess you could say like figure out magnitude and direction of that line. Like, is it kind of going at a 30-degree angle, 0-degree angle, what, and how fast is it moving, right? So in order to figure out resultant force, what you have to do is kind of know how it works. So to find the resultant force, okay, you're going to add up all the other forces that are there. So there's force 1, which I think is the bottom tugboat. I labeled it, and force 2 would be the top tugboat. Okay, so we know that and the way we're going to write those forces, not only do they have to have force, but also direction, because we're trying to give them a specific vector quantity to it. That way, when we add it together, our final answer, this F sub r, right, will be all the forces added together at once. So we got to basically write down all of our forces. So let's figure out force 1. Okay. Now, remember, based on the formula, we're going to find the magnitude of force 1, cosine theta I, plus the magnitude of force 1, sine theta j. Okay, that's the formula that we're going to use. Now, the magnitude of force 1 is pretty easy. Force 1, they told us, is 400 pounds. So I'm just going to write force 1 is 400. And then cosine of theta, so I'm going to look at the angle that's given to us, and they gave us a 20-degree angle. And so cosine 20-degree I. Plus, now the next one is 400. Sine of 20 degrees J. So there we go. We're done with that, okay? Not that hard to do. Just real quick, we wrote it out, and that's our first force. Now, force 2, that's going to be magnitude of force 2, cosine of theta I. I'm just writing these out just for the purpose of having them there for reference. Okay, sine of theta J. All right, so that's the way we're going to start off with force 2. Now, again, force 2 is 400 pounds. He said both boats were pushing at the same, with the same force. So force 2 is 400 cosine of negative 20 degrees I plus 400 sine of 20 degrees J. Now, if you guys remember, sine of negative 20 degrees. If you guys remember, there are identities that deal with sine and cosines that are positive and negatives, okay? So sine of negative theta is the same as negative sine of theta, okay? Sine of negative theta is the same as negative sine of theta, and cosine of negative theta is the same as cosine of theta. Okay, those are identities from trig. So that means that force 2, I can rewrite that as 400 cosine of 20 degrees I minus 400 sine of 20 degrees J. So here are my my forces right now, my two forces that I'm going to want to use to figure out my resultant force. So I want to find F sub r, my resultant force, using those two forces right there. Uh-huh.
The first 400 for force 2 be negative.
Oh no, but for cosine of negative 20, it's the so notice cosine of a negative angle is the same as cosine of a positive, right? So I don't need to change the sign for that one. Notice I didn't factor it. I use an identity. Okay, I did not factor the negative out. So the resultant force is force 1 plus force 2, right? So the way I'm going to write this out is by putting them on top of each other, basically. So we have 400 cosine of 20 degrees I plus 400 sine of 20 degrees J plus 400 cosine of 20 degrees I minus 400 sine of 20 degrees J. Well, 400 cosine of 20 degrees I plus 400 cosine of 20 degrees I is going to be 800 cosine of 20 degrees I. Now, positive 400 sine of 20 degrees J minus 400 sine of 20 degrees J is going to be 0 J. In other words, there's no vertical component to this. This is only moving horizontally. Okay, there is no vertical portion. Like you can cross this out. Okay, so all I have to do now is just figure out the actual value of 800 cosine 20, which comes out to 752. So my resultant force is that it's going to be moving at 752 I. Okay, now, so 752 I. Now, if you want to figure out its magnitude, we can do that. The magnitude is going to be the square root. Now, just so you guys know, let me write this out. This thing right here is 752 comma 0. Okay, that's its vector form. Okay, 752 comma 0, because it has no j component. Okay, so the magnitude is 752 squared plus 0 squared. So I mean, this was kind of obvious, but it's 752. That means it's going to be moving at 752 pounds. Okay, that's the force, 752 pounds in an eastward direction. Okay, because based on the picture you guys can see, it's going to be moving to the right. Okay, so you could say it's going to be moving at 752 pounds east. And that describes the vector, okay? Because remember, a vector needs magnitude and direction, right? So there's your magnitude and your direction. Mm-hmm.
If it was negative, does that mean it's going west?
Yeah.
So it was like negative 72?
Yes. So yeah, it's just going in a different direction. Because remember, your vector is basically, a negative vector means it's going the opposite way, right? So hopefully that's not too bad for you guys. You know, we're just adding vectors together and combining them to find the result. And we're going to do the same thing with this next problem, which is a little tricky. So that's why I would kind of wait for it till the end. But before I do that, any questions on this problem here? So notice we start off with, we know the resultant vector has to be composed of the two tugboats. So we kind of created the force vectors for those two tugboats, right? The force and direction for each one of those. When we got those two things, we added them together. I don't know why it's doing that. Sorry about that. But we added it together. And we noticed that the vertical component goes away. If you didn't change the negative 20, sine negative 20 into its identity, it still would have worked, just that you may have had to plug all this stuff into your calculator early to see that the numbers would cancel out. So don't worry if you forgot. It's a nice little trick for you to remember, so that when you do these problems, you might be able to eliminate things by doing that. But yeah, once you notice your value, 800 cosine 20, just put it into your calc at that point. Notice your calculator should be in degree mode for this problem, okay? Because we are talking about degrees here. And then if they want you to find magnitude and direction, all you have to do is kind of understand that you put that into your magnitude formula. And the direction, well, it depends on the picture, right? If the picture were to be going to the west and it stood negative, then you keep going west. If it was positive, you're going east, right? So it just depends on how the boats were pushing it. So, all right, here's the last example. This was example 6, so we're going to go to example number 7. All right, so let me write this problem out really quick, and then I'll continue with the video, but let me stop it right now. All right, so I will draw 2 pictures for this, okay, because it's important that we see both. But it says an airplane is traveling at a fixed altitude with negligible wind factor. So at first, wind doesn't matter. They say the plane is headed north 30 degrees west. So again, you start at north and then you move 30 degrees to the left, right? That's to our west. So that's 120 degrees at a speed of 500 miles an hour. As the plane reaches a certain point, it encounters wind with a velocity of 70 miles per hour in the direction of east 45 degrees north. What is the resultant speed and direction of this plane? So let me draw pictures here. I think I went too big on that one. All right, so first picture is going to depict, I guess say the original plane and the way it's traveling. So they said that the plane is traveling at a north 30 degrees west. So we'll put it about here. And we're going to call this velocity 1, okay? Because that's the initial velocity. And here's a poorly drawn airplane. Okay, so there's the airplane, and like I said, it's north 30 degrees west, which means that you start from the north, you go 30 degrees to the west, so that's going to be a 120 degree angle. Okay, so that's the initial drawing, okay, without wind. Okay, so I'll put that right here. No wind. That's to start. Now, eventually, wind hits. So I'm going to put right here, with wind. So the wind hits, and it pushes the airplane, okay? Now, the airplane is supposed to be here, okay? It's supposed to be there. But then the wind hits it at a 45 degree angle. Okay, we're going to call that velocity 2. So now the airplane is over here. We can call that V sub r. Okay, so now remember the wind they told us is traveling at east 45 degree north. So you go to the velocity 1, and at velocity 1, at the terminal point of velocity 1, you're going to draw an arrow at 45 degrees. Okay, so that's velocity 2. And then if we add those two together, V1 plus V2, that gives us VR. Okay, so let's write this down. V sub r is V sub 1 plus V sub 2. All right. So what's V sub 1? That would be magnitude of V sub 1 cosine theta I plus magnitude of V sub 1 sine theta j. Do I know the magnitude of V sub 1? Read the problem. V sub 1 is initial speed of plane. 500, right? So V sub 1 is 500. What's the angle? 120 plus 500 sine of 120 degrees j. So there's V sub 1. Okay, I'll highlight that for us. Now I need V sub 2. Right, I guess we can change it to, what color did I go to? Blue. So V sub 2, magnitude of V sub 2, cosine of theta I, plus magnitude of V sub 2, sine of theta j. So what's V sub 2 depicts the wind, right? So what was the speed of the wind? 70 miles an hour, okay. Cosine of, what was the angle? 45 degrees, right? East, 45 degrees north. So it's 45 degrees, so it's 70 sine of 45 degrees j. All right, so the resultant force is going to look like this. V sub r is V sub 1 plus V sub 2, which is, should probably, and I'm just going to change this up just so that we don't get mixed up with the colors, because I want the colors to kind of match up what we're doing. So that'd be V sub 1 plus V sub 2. So V sub r is V sub 1, which is, I forgot to highlight this, but let me do that really quickly. V sub 1 is 500 cosine of 120 degrees I plus 500 sine of 120 degrees j, then plus we have our wind, so it's 70 cosine of 45 degrees I plus 70 sine of 45 degrees j. That's what we're adding up. Now at this point you're going to want to get your calculator. You join your I values together, you join your j values together. Here's the values that we get. V sub r is, the I component is negative 200.5 I. Okay, and the y component is 482.5 j. Now if you really think about it, look at the point, okay, because remember this vector is giving you a point in vector form, right? Negative 200.5 comma 482.5. If you look at my picture, it is in quadrant 2, so it would be a negative x and a positive y. Okay, so that makes sense, negative x and a positive y. So if they want the speed, the magnitude of this thing, then I got to find the magnitude of V sub r, which would be the square root of negative 200.5 squared plus 482.5 squared. Okay, so I got to add those two things together. Okay, take the square of each, take the square root of it, and that gives me a magnitude of 522.5 That's miles per hour. So that's not so bad, okay? But the hard part can sometimes come out of the direction, okay? So what is the direction? So before I go into the direction part, I do want to do the following. I'm going to draw a picture of what we have so far. Now, not so much including the airplane and everything. Notice I'm just doing quadrant 3, okay? So I do know the resultant force of the plane, right? That's, let me not do the little arrow. That's 522.5. Now that comes from the x and y components of a, you could say negative 200.5 and a 482.5. Now, remember, negative 200.5 is not an actual distance. It's 200.5, okay? But I'm just putting it because of the fact that that's what this little point right here would be, right? A negative 200.5 comma 482.5. So, if I want to figure out this angle, okay, I could use, let's say, sine or cosine or whatever, right? It doesn't really matter which one I want to use, but let's just use sine, okay? Let's use sine, because that way I don't have to worry about the negative portion of it. So let's see. Sine of theta would be 482.5 over 522.5. So that means sine of theta is 0.92. So you do your sine inverse and we get this, 67.4 degrees. Is this plane traveling at 67.4 degrees? So let's look back at the original picture. I mean, here's the angle. Here's theta. Is that 67.4 degrees? No. What did I just figure out? Let me, if I can give you a little hint here. I just figured out 67.4 degrees, right? I found the supplementary angle for the actual answer, right? So yeah, do 180 minus 67.4, and you'll get your answer. So your actual theta value, so I'm going to call it, for us right here, 180 minus 67.4 degrees will be 112.6 degrees in quadrant 2, right? That's my actual solution. So they want us to write the resultant speed and direction. Okay, so now I get to do that. I get to write the resultant speed and direction. I know this, I know the magnitude, I know the direction, so here we go. The resultant vector is 522.5 cosine of 112.6 degrees I plus 522.5 sine of 112.6 degrees J. And that's what they want us to figure out. Now, if you have to explain to them the way to do this, I mean, you could tell them that the speed of the plane is approximately 522.5 miles per hour at an angle of 112.6 degrees. Or for the angle, you could also say that it's traveling west 67.4 degrees north. Okay, you could say west 67.4 degrees north. Or what would that other angle be? That'd be for 90 would be 22.6. So you could say it's traveling north at a 22.6 degree west, right? To make the same angle, or just say the actual angle, 112.6 degrees, right? Depends how creative you want to be. Okay, and also just mention its magnitude, so 522.5 miles per hour. Okay, so let me just kind of put that here. as an answer. And we're done. So let me give you guys your homework assignment. Let's see. You guys will have some time to work on this in class tomorrow, so we're not going to do anything in class tomorrow besides just work on homework. Trust me, you're going to want to work on this thing because these are all basically word problems at some point. So 21, 24, 31 through 40, 43, 81, 89, 93, and 94. So that's all the homework right there.